This is GCSE Physics revision for the OCR Gateway specification, and we're looking at section P1H, Unit 1, Section H, Stable Earth. In this section we'll cover earthquakes and ultraviolet radiation. We'll start with earthquakes. The study and detection of earthquakes involves the use of seismometers. Seismometers produce something called a seismograph, and you can see an example here. It literally shows vibrations. Earthquakes can cause a lot of damage to buildings, the surface of the earth, and they can also cause tsunamis, as we've seen a couple of examples recently in Southeast Asia and Japan. As well as surface waves, there are two types of waves which actually travel through the centre of the earth or beneath the ground, the seismic waves. The two types of waves are called P waves and S waves, and we're going to look at some of their properties. We'll start with P waves. The P stands for primary waves. This means that they travel more quickly, they get there faster. Now, primary waves are longitudinal waves. That means the particles that carry the P wave vibrate or oscillate backwards and forwards in the same direction in which the wave is travelling. P waves can travel through both solids and liquids. The second type of wave is called a secondary wave, or S wave for short. These travel more slowly, hence the name. This type of wave, S wave, is a transverse wave. That means even though the wave is travelling in one direction, for example left to right here, the particles that carry the energy or that transfer the wave are moving upwards and downwards. So if we've got the direction of travel here, the particles are actually moving backwards and forwards or up and down in this direction at right angles to the direction of travel. This type of wave, S waves, can only travel through solids. They cannot travel through liquids, and we'll see that this has been very important in deciphering what actually lies beneath the ground and the structure of the earth. So we're going to look now at how the study of seismic waves, and more specifically S waves and P waves, has led to an understanding of the structure of the earth. So we've got the epicentre of our earthquake here in one part of the globe. S waves and P waves can be detected around the globe on other parts of the earth, away from the actual location of the earthquake. Now, P waves, which we know can travel through solids and liquids, can be detected anywhere around the globe. S waves over here can be detected in some locations around the globe, but not in others. Now, this tells us that the Earth must have a liquid core, which is preventing these S waves from travelling through and being seen on the other side of the Earth. Let's move on to ultraviolet. The sun releases ultraviolet radiation, which can have some pleasant effects on us here, such as suntans. It can have less pleasant effects, such as sunburn, which can be painful. It also causes premature aging of the skin. And it can also have greater risks, which can cause health problems in people, such as cataracts and skin cancer. In recent years, people have been made much more aware of the dangers of UV, which is why the use of sunbeds has become less popular in the UK, and more people would go for a spray tan, perhaps, and also why people are much more likely to use sun cream now when they're out in the sun. There are various sources of protection we have available to us against UV, some of which are natural and some which are not. The first example is having darker skin. If you have darker skin, then you have more natural protection against UV. Our skin contains a pigment called melanin. It's a pigment which makes your skin brown, so the darker your skin is, the more melanin it contains. What melanin does is it absorbs UV. These outer layers of your skin here are actually dead skin cells. What melanin does is it absorbs the UV and prevents it from reaching the underlying living skin cells beneath. This prevents these cells from becoming damaged and possibly developing into tumours. The second method of protection against UV is using sun cream. You see on sun cream we often talk about factor 20 or factor 50, and that factor is actually short for sun protection factor, or SPF. The SPF tells you the maximum time you can be out for without burning, and we'll look at an example of that. To work out how long sun cream actually allows you to spend in the sun without burning, you would need to know roughly how long you could spend in the sun without burning if you were not wearing any sun cream. For example, if I knew I could spend 1 hour in the sun without any sun cream and I was wearing factor 20, I would do 1 times 20, and that would give me a maximum time of 20 hours in the sun. So in this example below, without sun cream, Felicity can spend 20 minutes in the sun before she burns. How long could she spend in the sun without burning if she were wearing factor 50 sun cream? So to work that out, we would say that the time is the maximum length of time without sun cream, which is 20 minutes, multiplied by the sun protection factor, which is 50 in this case. So now we have 20 times 50, which gives us 1,000 minutes. And if I divide that by 60, I get 16.7 hours. So we know that having darker skin offers greater protection against UV, as does using sun cream. The third method of protection is the ozone layer. This is a layer of gas high up in the Earth's atmosphere, and ozone absorbs UV. So just in the way that melanin prevents UV from reaching the living skin tissue, the ozone layer absorbs UV and prevents a lot of it from reaching the surface of the Earth. In the mid-80s, it was discovered that there was a big hole in the ozone layer above Antarctica. Some scientists had predicted for a while that ozone depletion was occurring, but it wasn't until new experiments were carried out by different groups of scientists around the world using different experimental techniques that people actually became convinced that it was an issue. It was discovered that it was caused by CFCs, and these CFCs are used globally in aerosols and refrigerants. The discovery resulted in an international ban on CFCs. It involved global cooperation because 1 or 2 countries acting in isolation would not have the necessary effect on reducing the amount of CFCs used and halting ozone depletion. Halting ozone depletion is actually one of the few environmental success stories that showing global cooperation and what that can achieve. With issues such as global warming, despite the fact that there are numerous different scientific investigations and numerous different pieces of evidence all leading to the idea that global warming is happening and it's happening quickly, and despite predictions of occurrences happening that are actually starting to happen, despite this, people are still reluctant to go along with the idea. And that is perhaps because it's easier to deny that it's happening than to tackle global warming, as it involves much more complex causes than a simple ban of the use of one substance. And that's it for P1.